Okay, so we're just going to quickly review all the circle properties we looked at so far. This first one, we're going to say that central equals central. So if you have an angle from center and the arc is so big, okay, then those two angles are equal. So if this is, say, 12 degrees, this is also 12 degrees. So central angles on equal arcs are equal. Okay, so this is a good study guide for us. Now the same is true for inscribed angles. So an inscribed angle, okay, we'll call this ABC. Angle ABC subtends arc AC. And for arc, we usually just use a little rainbow over top. Okay. So ABC subtends arc ABC. We can also say angle, this is new for you, ABC is inscribed arc ABC. Okay, so use all three letters to indicate this direction. So it's subtending arc AC, but inscribed in arc ABC. And we usually just refer to that as being inscribed in the circle. Okay, but you're going to see that in some review you're going to do, so I just want to mention it. It's not a big issue, and I don't really do a lot to test that. But this is showing that the green angle, if this is 13 degrees, then this is also 13 degrees. So inscribed angles on equal arcs are equal. Okay. Any questions with that one? Then we looked at this one. We have an essential angle. Okay. We'll call this X. And we also have an inscribed angle, which we will call Y. Okay. So the central angle is twice the inscribed angle. Okay. And saying it the other way around, the inscribed angle is half the central angle. Okay. So Y equals X divided by 2. I should write that in blue. And going the other direction, X equals 2Y. Okay, so you can do a little bit of algebra with that, and you saw that in your notes and also in your textbook to solve for X and Y if we're given some numbers. The next one we looked at was when you have a special central angle. Okay, so the diameter is a central angle, and the value of it is what? Straight line, 180 degrees. Okay. And no matter how you put it, the inscribed angle to the diameter is 90 degrees. So you have to know that you have to put down the green writing. Okay? That's what you have to do. We're not going to give you that. You have to know that. So watch out for that. I'll give you, that's one way of me telling you a number without having to write it down. Okay. Any questions with that one? Now I put the 180 degrees there so you can see this, the rule that we just covered to the left holds true. Okay, so 180 divided by 2 is 90. 90 times 2 is 180. This is just kind of identifying it. Okay. Next one, chord theory. So for chord theory, we had 3 parts, and we saw that yesterday. What are the 3 parts? What did I just draw? Line from center, or through center, whatever word you want to use. And here's our chord. What happens to the chord? Chord is bisected, which means cut in half. And the third part in red, the lines are perpendicular. Line and chord are perpendicular. So that line is called a perpendicular bisector. Means it crosses at 90s and cuts it in half. So you can put those together, just throwing that out there so you can recognize that's actually a name that you can name a line. Okay. Now our last one today is called a tangent line. So a tangent line is a line that touches the circle in only one spot. So touch right there. Okay, this here is a tangent line. And you do more work with those later and do some more investigations to higher level math. But if we have a line from center, okay, it will actually always touch the line at 90 degrees. So the rule that you have to have memorized is a line from center is perpendicular to the tangent line. And what we can do then is we can end up doing some Pythagoras with both of these. Okay. The only thing you're missing on your chord property is that sometimes you will have to draw the radius. Okay. So keep that in mind. Sometimes you will have to draw the radius. We'll give you a few problems with it drawn, but then the hard word problems, you know, separate the A's from the B's, high A's from low A's, you'll have to know to draw that. Okay. Any questions? So let's get started. So we talked about tangent lines a little bit. Here's your radius. Okay. Tangent line is drawn. D is the point of tangency. So this is where the tangent line connects to the circle. So it touches the circle at exactly 1 point. So it's not giving it a hug, it's just barely touching it, boom, one specific point in space, that's it. Right? And of course they join at 90 degrees, right? Which means they are perpendicular. Good. So let's have some question examples. Looking at example 1, what's the value for angle 1? 90 degrees. Right? It's a line from center touching the tangent line. So it's your tangent rule. Okay. What's angle 2? Well, let's leave angle 2. Let's find this angle right here. What is this angle? 180 minus 90 minus 50, which equals 40 degrees. Okay. Now the reason I found that is because now I can find angle 2. What's angle 2? The straight line is 180, and if you minus 40, you'll get angle 2. So it's 140 degrees. Okay. Good. So this is 140. This here is 40. What's angle 3? Look at 40 degrees. That's the central. So what would angle 3 be then? Half of that, 20 degrees. Okay, so the inscribed equals the central divided by 2. Angle 2 was angles on a line, right? Straight line. AOL equals 180. All right, now angle 4 is the tough one. Okay. So you need to mark on your triangle that it's isosceles. So this angle in here is what? What value? It's 20 degrees. Okay. So keep in mind, if you're looking at angle 1, it's 90, so the other side must be 90. So 90 minus 20 degrees must then equal angle 4. Okay, so angle 4 is 90 degrees minus 20. 70 degrees. We call that complementary. Okay, complementary. Angles add up to 90. So angle 4 plus angle 20 plus 20 degrees must equal 90 degrees. So we say those two angles are complementary. All right. Any questions? Notice how we had to find other angles first? That's going to start happening a little bit now. Those are harder questions, but we're getting close to that stage where we should be able to handle that. Okay. Example 2. AB is tangent to the circle at D, so mark that on your triangle. Sorry, mark that on your diagram. So everyone in class should have drawn 90 degrees. Okay. So we need to find the measure of angle 1. Well, in order to find the measure of angle 1, we need to know this top angle in the triangle, because then we can do our triangle rule. Go ahead, try and find the question mark. I'll give you a hint. You need to find this entire angle. Okay, find the entire angle in red. And 80 degrees will help you do that. So this entire big angle is the inscribed. And so that equals, so that's the central, pardon me. So that equals the inscribed times 2. So it equals 140 degrees. sorry, 160 degrees, pardon me. Right? So it's going to be 80 times 2. So then the question mark is 160 minus 140 equals 20 degrees. So angle 1 is real easy then. Angle 1 is the total value of a triangle minus 90 minus 20 equals 70 degrees. And that's your answer. Okay, that's a hard question because we leave it wide open. So you got to try and find all the different angles to help you. Ask yourself, what do I need to find to get that angle? Okay, you got to do some work, some thinking. And of course, number 3, a little bit of Pythagoras. Okay, mark those numbers on your triangle, try and solve. Go. Okay, so you got to find BD by doing Pythagoras. So it should be 25 squared minus 7 squared. Use your calculator. Go. Okay, so BD equals 24. Then what's the length of BE? This whole thing is 24. Well, then CB must be half of that, 12. And so they're all 12. Okay. What's angle BED? Well, it's got to be 90 degrees. That's because it's inscribed to the diameter. Now you can find the length of DE. Okay, so find the length of DE now. You're going to do Pythagoras again. Okay, 20.8. Okay, so DE is 20.8. Any questions? Thumbs up, you got 20.8.